Hello friends, welcome to Bindu Dhadwal chemistry lessons. Our topic for today is behavior of real gases, deviation from ideal gas behavior. A gas which obeys the general gas equation PV is equal to nRT and other gas laws at all temperature and pressures is called an ideal gas or perfect gas. तो एक आइडियल गैस का प्रेशर वॉल्यूम प्रोडक्ट जो है वो nRT के बराबर होता है. लेकिन जैसे जैसे प्रेशर हाई होता है और टेम्परेचर लो होता है, जो रियल गैसेस होती हैं वो आइडियल गैस बिहेवियर से डेविएट कर जाती हैं और दूसरे गैस लॉज में भी डेविएट कर जाती हैं. तो ऐसी गैसेस जो इस आइडियल गैस इक्वेशन को ओबे नहीं करती हैं उनको हम real gases या non-ideal gas कहते हैं. The gas which does not obey general gas equation and other gas laws at all temperature and pressures is called non-ideal gas or real gas. Most of the real gas show ideal behavior at low pressure and high temperature, but at high pressure and low temperature they deviate from ideal behavior. Amagat and Andrew and other scientists made extensive study of behavior of various gases under different conditions of temperature and pressure. अगर एक ideal gas होगी तो अगर उसके Boyle's law में PV is equal to कांस्टेंट होता है, प्रेशर वॉल्यूम प्रोडक्ट इज कांस्टेंट एट ऑल प्रेशर्स. तो अगर आइडियल गैस होगी तो उसका जो प्लॉट है पीवी वर्सेस पी, वो इट विल बी स्ट्रेट लाइन पैरेलल टू द पी एक्सिस. So according to Boyle's law, PV will be constant and PV versus P plots at all pressures will be a straight line parallel to x-axis. But for real gases, there is a significant deviation from this behavior. There are two types of curves are observed. For gases such as hydrogen and helium, the curves are ascending with the increase in pressure. A straight line increasing with the increase in pressure. But for gases like carbon monoxide and methane, they show first negative deviation, reach to a minimum, and then they start increasing with the increase in pressure. This behavior, this deviation from ideal gas behavior can also be seen in the pressure versus volume curve. So this is a curve for ideal gas and this is the curve for real gas. The two are not coinciding. You see that at a high pressure, the volume occupied by real gas is greater than their volume should have been occupied had it been an ideal gas. So at high pressure the measured volume is more than the calculated volume. However, at low pressures measured and calculated volume almost approach each other. We can measure the deviations from ideal behavior. Two factors can be studied. One is effect of pressure. A very simple way to study deviations of real gases from ideal behavior is to plot a graph between PV upon nRT and P. Now PV upon nRT, this quantity is called compressibility factor and is denoted by the letter Z. So compressibility factor Z is equal to PV upon nRT. When you plot PV upon nRT versus P, the PV upon nRT, if PV is equal to nRT, then Z value will be 1. So for ideal gas, as PV is equal to nRT, the value is 1 at all pressures. So the graph is a straight line which is parallel to the P axis. But for real gases, the value of Z is not equal to 1. It is either greater than 1 or less than 1. So for real gases, Z may be less than 1 or more than 1. Thus PV is not equal to nRT for real gases. And in the plot we can see that Z can have values greater than 1 and less than 1. If Z is less than 1, it is called negative deviation, from ideal gas, it means that the gas is more compressible than expected from the ideal behavior. These gases can be liquefied also. They can be compressed because they show negative deviation from ideal behavior. And gases like hydrogen and helium have the value of Z greater than 1. It means that gas is less compressible as expected from its ideal behavior. At low pressures, you will observe that deviation from ideal behavior is very less, and it is almost equal to 1. The compressibility factor is almost equal to 1 at low zero pressures for all gases. All gases start from here. The curves for all gases start from 1. So at pressure 0, there it is almost showing ideal behavior. At high pressures, the Z is at pressures say higher, at these high pressures, these values, Z is greater than unity. The extent of deviation at any pressure or temperature will depend upon the nature of gas. You can see for carbon dioxide deviation is more, but for nitrogen it's appreciably nearer the ideal gas behavior. Z approaches unity as pressure approaches 0. For hydrogen and helium, Z is always greater than 1. So these are less compressible than expected from ideal behavior. And gases like nitrogen, oxygen, methane, carbon dioxide, they first show negative deviation, reach a minimum, then reach high up and increase, show greater deviation. So the deviation is greater than 1 at higher pressures. The effect of temperature on the behavior of real gases can be seen by comparing the behavior of nitrogen gas at different temperatures. So here T1 temperature is less than that of T2, then T3, then T4. For the same gas, you can see that at lower temperature the dip is bigger, and as we move to higher temperature the deviation gets reduced. So at higher temperatures it's more or less showing ideal behavior at a fair range of pressure. So the dip in the curve goes on becoming smaller and smaller as the temperature increases, and the temperature at which the dip is minimum, rather the minimum in the curve is has vanished, it has disappeared, and the curve remains horizontal for an appreciable range of pressure. This temperature is called the Boyle's temperature or Boyle point. The temperature at which real gas obeys ideal gas law over an appreciable range of pressure is called Boyle's temperature or Boyle point. Boyle temperature is different for different gases. For nitrogen, Boyle temperature is 59 degrees centigrade. For hydrogen, it is minus 165 degrees centigrade. Above the Boyle point, the real gases show positive deviation from ideality. They are showing positive deviation above the Boyle's point, and below the Boyle's point they are showing decrease in Z value with increasing pressure. It reaches a minimum value, and on further increase in pressure the value of Z increases continuously. So this means that at low pressure and high temperature gases show ideal behavior. The conditions are different for different gases. Also, we can have more insight of the significance of Z. Now you see Z is PV upon nRT. If the gas shows ideal behavior, then for ideal behavior Z is 1. So this equation becomes 1 is equal to PV ideal upon nRT. V ideal will be nRT upon P. So substituting this value of V ideal for a real gas, instead of nRT upon P, we will write V ideal. So we get Z is equal to V real upon V ideal. So compressibility factor can be defined as the ratio of actual molar volume of a gas to the molar volume of it if it were an ideal gas at that temperature and pressure. So we have seen that real gases deviate from ideal gas behavior. Why they do so, we will take up in the next video. Thank you. Have a nice day.